Hello, chemistry students. Here are the corrections for page 181, questions 11, 13, and 14. Question 11. Describe the relationship between Avogadro's number and 1 mole of any substance. So this is that idea that 1 mole of substance equals Avogadro's number, which is the 6.022 times 10 to the 23rd, representative particles of that substance. Okay, now remember, we can write these as conversion factors. That's how we'll be using them for math, or for our math in this chapter. So 1 mole of an element, that's a substance, is 6.022 times 10 to the 23rd atoms, remember, because the representative particle of an element is an atom. 1 mole of ionic compound is Avogadro's number, formula units of that same compound. Okay, because again, a formula unit is the smallest piece of an ionic compound. And finally, 1 mole of molecular compound is Avogadro's number of molecules. Your textbook says 1 mole of any substance contains Avogadro's number, 6.02 times 10 to the 23rd of representative particles. Number 13, how many oxygen atoms are in a representative particle of each substance? This does not require math. So if you were trying to do some math, you made this question harder than it needed to be. All this is saying is in 1 formula unit of NH4NO3, there are going to be 3 oxygen atoms, right? Because the subscript on oxygen is 3. In 1 molecule of acetylsalicylic acid, there are going to be 4 oxygen atoms. In 1 molecule of ozone, there are going to be 3 oxygen atoms. And lastly, in 1, we'll say molecule of nitroglycerin, C3H5NO3, there are going to be 9 oxygen atoms. And again, that 9 comes from the 3 times the 3 there. So really no math required in terms of showing work to answer that question. Number 14, how many moles is each of the following? So this is asking us to take this and figure out how many moles of NH3 this is. So again, I'm going to start with my given, which is the 1.50 times 10 to the 23rd molecules of NH3. Molecules of NH3 have to go in the bottom, so they'll cross out. When I look at my tools that I have on my toolkit, I can convert molecules to moles. 1 mole is Avogadro's number. Okay. So molecules of ammonia are crossing out with molecules of ammonia. I'm going to be left with moles of ammonia. And significant figures wise, I have 3 sig figs here, so my answer can have 3 sig figs. So you should end up with 0.249 moles of ammonia. Again, how do you put that in your calculator? Okay. To put that in your calculator, 1.5 E23. I'm dividing because Avogadro's number is in the denominator. E23 should give you your answer. Letter B, again, we're asking to take this and figure out how many moles of oxygen this is. So again, I'm going to start with 1 times 10 to the 9th molecules of O2. Molecules of O2 have to go on the bottom. I can convert that to moles of O2 using Avogadro's number. 1 mole is Avogadro's number. So again, molecules are crossing out. I'm going to be left with an answer in moles. This number here only has one significant figure. So you should get an answer of 2 times 10 to the negative 15th moles of oxygen. Again, to kind of show you how you might put that in your calculator, 1E9 divided by, because again, my Avogadro's number is in the denominator, E23. All right. Letter C, once again, is asking me to figure out how many moles of bromine this is. So again, I'm starting with 6.02 times 10 to the 22nd molecules of bromine. Molecules of bromine have to go on the bottom. Moles of bromine are going to go on the top. 1 mole is Avogadro's number. Molecules are crossing out. And 6.02 has 3 sig figs, so my answer should have 3 significant figures. So you should end up with 0.100 moles of bromine. Again, to put that in your calculator, you're going to do 6.02 E22 divided by 6.022 E23. Letter D is asking me again to take this and figure out how many moles of lithium this is. So I'm starting with 4.81 times 10 to the 24th atoms of lithium. Now lithium is an element, so I can take atoms of lithium to moles of lithium because the representative particle of an element is an atom. 1 mole is Avogadro's number. Again, atoms of lithium are crossing out. I have 3 sig figs here, so my answer should have 3 significant figures. So you should end up with 7.99 moles of lithium. Again, how do you put that in your calculator in case that's part of what you're having a problem with? 4.81 E24 divided by 6.022 E23 should give you your answer. So I hope that helps if you had some questions on this homework assignment. Have a good day.